Hey guys, how's it going? This is lecture 9 where we will be discussing about OOPS part 2. In this lecture, we will be going to see how does OOPS work. Also, previous lecture we have learned about abstraction and encapsulation. In this lecture, we will be discussing about inheritance and polymorphism. How does these work? How to write code in these? And basically, how does it work actually in our code? So this is part 2. Part 1 has been uploaded earlier. So let's start. So we have seen what does OOPS means, object oriented programming, right? And we have also seen how to write class, what are objects, what are attributes. All these has been covered in part 1. So you can see here, it's the architectural blueprint, how to write anything in OOPS. So first is life cycle, right? It's a component creation and targeted distribution. The next step is security, that is encapsulation and private machines mechanisms. And third is hierarchy. What does it means? Indirectly, it means inheritance, the ancestral bridge, right? And the fourth is dynamic. What does this means? It means reactive attributes and method ecosystem. And fifth is magic. What does this means? Polymorphism and alternative fundamental operators. Right. So this code we will be seeing this. We will be taking this as a question and we will be practically doing it. We will be there now. One of the most important thing in OOPS is delete. How does delete work in OOPS? So what is a delete? Delete in basically in Python is a keyword, right? You can't use this as a variable name. Now, object occupy memory space. Need objects or specific attribute can be deliberately wiped from memory using del to actively manage the system's footprint, right? Now, how does delete works? So if you are seeing here, we have seen S1, we have assigned student into S1 and we named it as Shraddha. Now, if I want to delete something, what I would do, I would use del s1.name and it would be deleting it, right? So rather than understanding this thing, let us write this in our code. So let's open our VS code. Let's make one file. So yeah, first of all, let us make a class of student. And how to make class? We have to write class over here, then student, then we have to define our init function. Inside that we have to write self, it's mandatory. And let us suppose we are giving name over here. Now self dot name is equal to name. Now what is this? I have created a class of student. Right now I have to create object. How to do that? I will be assigning my student to S1 with my name, then I would be printing my s1 dot name. So let us first print this. Let us see, will my name be there? Yeah, my name is there. Ayush is there. Okay. So my name has been printed. Now, if I want to delete it, what would I do? Is I would use del keyword over here, del s1, and it would get deleted. Let's suppose after that, if I'm printing my name, will it print my name? Let's see. So yeah, firstly, it has been printed by name, and second, name s1 is not defined, right? So this thing has been deleted, right? So let's run this after removing that. So just Ayush would be printed, and if you print again, then it will show me an error. Why? Because my name has been deleted, right? This is one thing that you have to see. How does delete work? Now, okay, now comes a very important part, that is in Python we have two type of codes. First thing would be public one, where the information can be accessed by everybody because it's public, and the private one, that the authorized authority can only see that code, means the output. So, okay, in private, attributes and method are meant to be used only within the class and are not accessible from outside the class. So what does this means? So in private, you can only access the information from the class. What does class means? This thing. You can't get the information by using outside the class, which is this thing. You can't access the information from object. See, in this case, I'm taking from the object and I'm printing from the object. So let us take one example and let us do that. So encapsulation, securing the what, right? That is what encapsulation means. So let us read the definition. Prefixing an attribute with a double underscore. So how you can make anything private by using double underscore in front of it. Then it's private. Nobody can access it rather than you. So double underscore making it unspecifically private, strictly preventing external access and securing the class state from accidental modification. Right? So nobody other third party could not modify that thing. Right? So in this example, as you can see, the account number is a public one, right? We can give our account number to my friends or to other person. But what about the account password? It's a private thing. So nobody should use it. And how to make account password private? By using double underscore towards the front, not at the back side, at the front. So in this case, here is one example, class account. So we have made an account class, and we inside that we have assigned account number and account password. So here, if you can see here, I have used an account before the account password. I have used a double underscore here. So this means it is secured with the class vault. That means it cannot be accessed outside the class. It can be accessed inside the class. We will be seeing it. How does it that works? But outside the class, it won't get printed. It won't show you the password. So here I've assigned accounts to ACC1 and I will be printing the ACC1 dot account number. It would get printed. Account number is would be get printed. That is 12345. But what if I want to print my account password? It would not get printed. Why? Because of double underscore. That is private. So it will be showing me an attribute error. Account object has no attribute. Let us see this code in practical. How to write this code? How does it work? We will be seeing there right now. Let us delete this. So class account def init self comma account number comma account password. Now, yep. Now self dot account number equal to account number self dot account password equal to account. I have not created this into private, so let us create this into private by using double underscore. From this we have created this into private, right, by using double underscore. Now this is my class. Now let us assign this into S1. Let us create this into account 1 so that it won't get confused. Account, and let us put the value of account number as 12345, and I don't want my account password should be shown. So let's suppose I'm using my account password as some good password right here. And now let us access my account number and account password outside the class. Let us see. Account number would get printed. Let's see if account bridge. Super. The super method allows us a derived class to dynamically access for its parents weak. The super method allows. Okay. Ensuring fundamental attributes are recognized initialized before adding custom specifications. So here have an employee with role, department, and salary. It is being initially payload routing. It is taking the information from here to here. Using what? Using the super keyword. And it is assigning those value here itself. That is engineer. The role is engineer. Department is IT and he's earning somewhere around 75,000. So that what super does, right? Now, the chart is important. The method ecosystem matrix decorator used in instance method, the decorator used is none. But in the class method, we use class method. And in static method, static method. What about first argument? We use just self. What is this? It's an object. And here the class. And here static method, it is none. But can we modify class blueprint in instance method? No. But in class method, yes, we can. But in static method, no. But what if we can modify the object state? Yes, we can do in instance method, but we can't do these in both of these. That is class method and static method. The primary unit of instance method is standard operation utilizing unique object attributes. And in class method, the primary utility is chanting shared variable across the entire architecture. And the starting method, the primary utility is isolated utility functions. Example, pure mathematics, right? Now, here is one example of class method we will be seeing here. Build a method of CS ensure the state change, manipulate the fundamentals blueprint itself rather than accidentally fragmenting into isolate instance variable. So here person is named as anonymous. It's a base class attribute. Now we have used class method over here. And if I want to change the blueprint, that means if I want to change my name anonymous to something, I will be using def change name, cls new name, and I will be assigning the new name. But make sure you have to write person dot change name, that is this thing dot this thing and your name. And after that, your name would be Rahul Kumar, right? Now, here comes a most interesting part where we will be using two example and seeing that how does it work. The property decorator. How does the property decorator work? Transform a method into an attribute. It recalculates into value dynamically, whether a seed eliminates stale state data corruption. So let us take two scenarios where there is stale state, that is no decorator. We are not using the property decorator over here. So let's suppose I got 98 marks in physics and more two subjects are there, that is chemistry and maths. And let's suppose my physics marks is 98 and I'm totally getting 98.7 percentage in my these three subjects. And if in future, if I want to update it, I can update my physics mark to 86. But what if I want to know the percentage of my now the new physics marks included in that? But it would be showing me error. It will be not showing me an error, but it should be showing me 98.7. That is the previous output. it would be showing me that because it is taking the data of physics as 98. But with using my property decorator, if I've changed my physics marks to 86, it would be accessing the S1 dot percentage. I would be doing this and trigger recalculate. And after that, my percentage would be changed to 94.0%. Let's do this in my code. So, class student def, these are my four subjects, and let us. So now self dot physics, now self dot chemistry, now self dot math would be equal to math. Now I'm assigning here to get my percentage. So self dot percentage to self dot physics plus self dot chemistry plus self dot math divided by 3. After that, my class has been created. Now I will assign this to my student 1 student. Let us give my values as 98, 97, 99, and I would be printing the student 1 dot percentage. So yeah, 98% I got. Now if I want to change my marks of physics 86, after that I would be printing the physics marks and let's also print my percentage. It would not show me my percentage because this thing don't work using. So here I've changed my physics marks to 86. 86 has been printed, but what about my percentage? It is showing me the same percentage as above, while it should get changed. So how to do that? By using property decorators, right? By using the property decorator. So here, what you can do is you can write def calculate percentage percentage. Let us call this to my, let us write this. here. Okay, now this thing has been done and let's run this code. Okay, so wait, same error. So it should be return. Student object has no attribute percentage. So where is percentage? Okay, okay, I think I've made some mistake. So let us see this thing right. So using the property function, you can easily get the percentage of your marks, right? Now, here comes polymorphism. So what does poly means? Poly means many and morph means form. In Python, a single operator automatically adapts its behavior depending on the structural context of the data passing through it. So whether the data is integer, whether it's a string, whether it's a list, it would add those. That's what polymorphism means. And it will be getting you the value. That is 3 here, Apna college, and 1, 2, 3, 4, 5, 6 here. And the hidden writing, that is dumper method. What does that mean? Double underscore dumper method allow us to define custom logic for building in operation. We inspect standard symbols and route them to our custom engineering logic. Like for example, over here, def double underscore init self items price, and here order. So it is returning me if the price is greater than price of 2, it should print me the order 1. That is the order which I have kept. That is the scripts, right? It would be returning me that. So this is one example that you can see of polymorphism, that how you can add these two, which are complex number. So this is one uh, program over here. Now, this is the architecture, how it completes the base blueprint of polymorphism. All right, you can go through this. So before ending our lecture, let us do one question where where will we be. So I will be reading the question so that it is understandable. So the question is, define a circle class to create a circle with radius r using a constructor. Define an area method of the class which calculate the area of circle. Define a perimeter method of class which allow you to calculate the perimeter of the circle. So I will be reading one more time. So I have to define a class of circle to create a circle with radius r using constructor. So inside the self, I will be also writing radius, right? And I will be defining one more there, that is area to find the area, and then perimeter to find the perimeter of the circle. So let us create the class of circle where we'll be defining self and radius. Now self dot radius equal radius to radius. Now it is showing me to area. Now self, and what is the formula of area of the circle? That is 22 divided by 7 multiply by self dot radius. I am not using just radius. I'm using at self dot radius 2. Now same with my perimeter. Return 2 multiply by 22 by 7. Okay. Self dot radius. Now everything is been done. Now I'll be assigning this to circle. Let us assign the value of radius as 21 and let us print the area first, and also let us print the perimeter. Yeah, let us print this. So the perimeter of the circle is 1386 and the the area is 1386 and perimeter is 132. So this is one question that we have done, one of the important question. So that's it. Now I guess everything is being cleared, that how does it works, how does delete work, what does our internal mechanism, that private method, how to make anything into public and private. In public everybody can see that, and in private outside the class it won't get visible, right? And how to make that into private by using double underscore in front of it if you whatever you want to show. Now architecture, how does this work? And we have four types of inheritance: single inheritance, multi-level inheritance, and multiple inheritance. Now our ancestral bridge, how does this work? We have seen it. And this table, which is one of the most important one, that how does decorator use in instance method, class method, and static method. Also about the class method, how does class method works if you want to change any data like your name, something. And the property method, we have also seen this using an example. You can go through this one. And polymorphism, how does this works? Poly means many, morph means form. Hiding data, same thing. This is one example you can go through. And this one of the architecture, the complete architecture of polymorphic dumper code. And this is one last question we have done. If you want to change the value, that's your wish. Right. The only thing you want to focus here is the formula and how to write that code. That's it. So I guess that's it for the part two. Our Python has been completed. So in next video lecture, we would be making some Python projects, some calculator, weather apps, and all those things. So that's it, everybody listening to me. Hope everybody has understood everything easily. That's it, and thank you and goodbye.